In this part, we're going to start coding in Godot. And Godot supports quite a few different programming languages. Some really big ones are C++, C Sharp, and Rust. However, by default, Godot uses what is called GDScript, which is incredibly similar to Python. In fact, if you know Python, you basically know GDScript. Since that is the easiest one to get started with, it's also the one I will be using. However, for the purposes of this tutorial, I will assume that you already have some basic coding knowledge. All you really have to know is basic things like a function, for loops, methods, things like that. For this entire tutorial, we are never going to do anything terribly complex in code. So the most complex thing we are going to do is a for loop. It's really not going to be difficult. Even if you have never coded before, you should still be able to follow along, although it's going to be a bit more difficult. Now, what I would recommend is to have a look at some basic coding tutorial. Here's one for Python and one for JavaScript. Both will prepare you pretty well for using Godot. Just choose whatever, both would be perfect. Just choose whatever you like more. And if you happen to like my voice, I made the Python tutorial as well. Those two would connect reasonably well. But anyway, when we are writing code in Godot, we are always attaching a script to a node. And then this script can change the attributes of that node. This can be quite a few different things. For example, you could change the position, size, rotation, texture of whatever node you are working with. If there's an attribute in the inspector, you can change it via code. Let's have a look at that actually. So here we are back in Godot, and for now I want to work inside of the player. More specifically, I want to look at the player image. If you look at that and for example go to transform and hover over position, there you can see property position, all in lowercase letters. Or I could go to rotation, and there we have rotation or rotation degrees. You can also do the same thing for scale and for skew. They all work in basically the same way. All of them basically tell you how to target this property via a script. For that though, first of all, we have to attach a script to one of the nodes, and usually this happens to the parent node, although it doesn't have to be. All you have to do is have a node selected and then click on the script icon. If I click on that, we are getting a couple of options. At the top, we can select a language. By default, you only have GDScript. Then we have inherit. This one you usually leave as it is. Don't worry too much about it. Class name you can also ignore. The more important one is a template. There we have default and empty. And let's start with default. Godot actually explains right below what is going to happen. Template only means that we have a couple of basic functions inside of the script. Finally, the last important thing is the path to the script file. And usually you are storing the script in the same folder where you have stored the scene. In my case, I'm going to store player.gd inside of the scenes folder. And with all of that, let's click on create. And then you can see we have a couple of lines of code already. We have extends node2d, then we have underscore ready and underscore process, along with a couple of comments. To go over all of them really quickly. Extends node2d you have to have in there, and this node2d has to match with the node that it is attached to. For example, right now we have a script in the player node. And if I hover over this, you can see this node has a type node2d. Because of that, we want to extend in node2d to get all of the attributes of this node. Godot usually does this automatically, so you don't have to worry about it. Just make sure you don't delete it. After that, we have two functions, and a function in Godot is created via the func keyword. And then, like in Python, you have a semicolon. After that, you have indented code, and in this indented code, you can add whatever code you would like to have. On top of that, some functions are pre-made in Godot. You can see two already actually. Ready and process. Ready is being run when we are attaching a node to the scene tree. I.e., when we are creating a node, this function is going to be run. And process is going to be run on every single frame of the game. You can also see that this one has a delta parameter, and this one is inserted automatically. Via delta, you can account for frame rate differences. I'll talk about this in just a second. Now, basically what you would be doing inside, for example, the process function. you would target one of the attributes I just talked about. For example, if you want to have the position, you would simply type position. And Godot is giving you a couple of hints already. I want to have the position. And this position you could set to a specific value. Now for the position, we will need a vector 2, simply because we have x and y. Meaning in there, we want to specify an x and a y value. And just to have some random values, let's say I want to have x being 100 and y being 200. After we have all of that, Godot stops complaining, and now we are setting the position of this player node 2D to 100 and 200 on every single frame of the game, which isn't going to be terribly useful, but for now it's a good start. So now, if I return to 2D, right now nothing is going to happen. That is because we are not running the script, and for that you have to look at the top right. There we have a couple of icons. The most important one is all the way on the left, and this says Run Project. If you click on that, you are going to get another dialog where we have to select a default scene. What that means is that Godot wants to have one scene that will be run when the game starts. In there, we could select a scene or select the current one. Now in my case, I want to click on Select, and then select the level scene. And now we can see we have the actual window. So that's a really good start. On top of that, what is really important is the position of the ship. If you look at it closely, we have the ship right here. However, if I go back to the editor and look at the level, we can see that the ship isn't in this exact position, although this is quite difficult to see. Let's close the game again, and when we are placing the player, I want the player to be in the top left. And now if I run the game again, which I can do by clicking on the triangle, now we can see that the player is still in the other position. And that is because of the script that we have written that places the player always in this particular spot. And also, I should explain that the window is a grid that starts in the top left, meaning when we are placing the player 100 pixels to the right and 200 pixels down, we are starting from the top left. But other than that, we simply have basic coordinates. Also, on top of that, if you go to Project, Project Settings, and then under Window, you can set the window dimension, and that window is a bit small, that looks much better. By default, the viewport width and height is 1152 by 648. I think a much more common one would be 1280 by 720. And now, if you close this dialog, the blue border around it has increased by a little bit. If I run the game again, it's not going to be terribly visible. Or actually it is. We can now see that the background isn't entirely covered anymore. And that we can fix quite easily. All we have to do is drag the background so it covers everything. Let's try. And that looks almost correct. So with the background selected, I want to go to Transform and then increase the scale by just a bit. And I should show my mouse for all of this. So we are in Transform, and I clicked on Scale and simply drag this one up a bit. So we are covering the entirety of the background. If I now run this again, this is much better. Cool. With that, we can return to script and then have a look at what else we can do. At the moment, we are always placing the position of the node 2D, to be more specific, the player node 2D, at this particular position, which arguably isn't too helpful. What we can also do is change the position. And this you can, for example, do with plus equal. We want to change the position by a certain amount on every single frame of the game. For that, we will still need a vector 2 for the direction. For this one, let's go with 1 and 0. That way, we are only going to the right. Although this would be very, very slow. So I want to multiply all of this with, let's say, 50. And now if I run all of this again, you can see that the ship is moving to the right. Although, if I run all of this again, you can see the ship is all the way in the top, meaning the starting position was this point, which should make sense because this is where we are placing the ship by default. You can find all of that in the 2D scene, in the level. This is the starting position of the ship. And all we're doing is moving the ship to the right on every single frame of the game. We could account for that in a couple of different ways. For example, what we could do is place the ship somewhere here, and now if we run the game, the ship starts from this position and moves to the right. What we could also do, if I return the ship to the origin point, I could look at the script and work inside of the ready function. This one is only going to run once when the scene is ready. And in there, we could target the position again, and then set it to a certain value, once again via a vector 2. For example, this could be, let's say, 100 pixels from the left and 500 pixels from the top. If I now run all of this again, we have the ship starting at this bottom bit. And that's basically all you have to know about the ready function and the process function. The only difference between them is that process is being called continuously, while ready is only called once. Also, what can be quite confusing for beginners is that at the moment we are working inside of the Node2D of the player. So we are attaching a script to it. But when you look at the top, we have the level scene selected. And what would be more appropriate here is to have the player scene open because this is the one we are working in. The thing you have to understand is that we can have a scene open and the script might be for another scene. This can be a bit confusing. So I hope this makes sense. There are two important concepts that we have to cover. The first one is delta time. This one helps you to account for frame rate differences. So if I run the game, my spaceship has a certain speed, but on your computer this might be much faster or much slower, depending on the hardware of your computer. Basically, the problem is that Godot is trying to run this line as fast as it can. On a fast computer, it might be able to execute this line 1,000 times. On a slow computer, it might only be able to do it 30 times. And since we're updating the position on every single frame, if your computer can run faster, it will do this operation more often per second. And to account for that, you have to add delta time. And if you spell it correctly, that will also help a lot. Delta is the elapsed time since the last frame. The comment here explains this one quite well, actually. This difference is going to be smaller the faster your computer is running. For example, if your computer can run the game at 1000 frames per second, the difference between each frame is going to be 1 millisecond, a very short amount of time. However, if you're going to run the game at 60 frames per second, the difference between each frame in terms of time is going to be about 16 to 17 milliseconds. All of this combined basically means that the faster your computer is, the smaller delta time will be. And if your computer is slower, delta time will be larger. Because of that, delta time will counteract this line being called more often on a faster computer. And if you're interested in the math, here's a slide that explains all of this in a bit more detail. Just pause it now and read through it. But anyway, if I run the game again, we can see that the ship is now running significantly slower. However, it should run at the same speed on any computer, which is the really important thing that we wanted to cover. And that's the first issue I wanted to address. Next up is that sometimes we only want to change an attribute of the sprite 2D and not of the entire scene. So at the moment, we are changing all of the children nodes of this player. If we had multiple, they would all go along with this parent node. As a matter of fact, let me duplicate the player ship a couple of times, which I can do with Ctrl and B. And let me simply place all of them somewhere like this. If I now run the entire game again, we can see that all of the ships are moving at the same speed. And I should have moved the last one something like this, so you can actually see it. There we go. All of the ships, or rather the entire scene, is moving to the right. And this is not necessarily what you want. Sometimes you only want to target one specific child node. You can do that in two ways. One way would be to use the function get_node. And then Godot is already giving you a couple of default options. You want to have a string with the name of the node. There we have the player image. Once you have that, you can use this like any other node. For example, you could update the rotation and increase it by a very small amount. Let's say 0.1. And don't forget, also multiply this by delta. If I now run all of this again, we have the ship rotating by a certain amount. And I suppose, let me duplicate player image again and move it to a slightly different spot so we can see what's going on. If I now run the game again, only one of the ships is rotating because this is the only node that we are targeting via script. Although you don't really see this kind of line very often because it's kind of extensive for what you want to do. Instead, what is much more common is a dollar sign and then the name of the node. So in my case, player image. This is doing the exact same thing. It simply gives you a node and then you can work with this node. And this is much easier to read and shorter, and you are getting the same result. Hence, this is the much more common way to address a node. Also, what you could be doing, if I get rid of this again, you can simply drag and drop a node into the script, and then you get the same outcome, which can be quite handy if you have a very long name. But alright, with that, we can target one specific node or all of a scene. Also, I don't want to have the player image 2 anymore. We only want to have a single player image. And alright, with that, we have already covered a really important starting point. But when it comes to coding, there's quite a bit of material that you have to understand. And Godot is fully aware of that, and because of that, in the top, we have a help bar. And there you can click on Search Help. If you open that, you can look at a lot of different things. Basically, whatever you could be looking at. For example, if you want to know about a vector 2, then Godot is giving you quite a bit of information about it. Basically, the documentation is built right into the editor. And working with this is incredibly important. So we are going to do an exercise right away. I want you guys to read through the documentation and figure out how to get input. There are quite a few different ways of doing that. Just try to find one way. It doesn't really matter which, just make sure you can get input and move the ship from that. Pause the video now and play around. See how far you get. Back in Godot. To get started, I want to search help and then type in input. This is going to bring me to an input class, which looks pretty good. There we get a few descriptions, and if you scroll down, you can get all of the input methods inside of Godot. For example, a fairly easy one is action just pressed or is action pressed? This one looks for one specific action, which should be just a name of a string. We can specify that later on. The thing we are going to use in just a bit is going to be called getVector, but that's going to come later. For now, let's try to figure out how to use isActionPressed. If you click on that, you get a bit more detail on what this particular method is doing. So let's use it. And for that, I want to work inside of the player. Specifically, I want to work inside of the process function. In there, first of all, we will need the input class. And in there, if you press dot, you get the different ways to get input. For example, in there, we could check for isActionPressed. After that, we are going to need a name for what kind of input we are looking for. Godot has a couple of default ones. For example, UI down is simply the down key on the keyboard. And once we have that, Godot is going to return either true or false depending on this button being pressed or not, which we can print. So let me wrap all of this into a print statement, run the entire code again. And now if you look at the bottom, there we have an output, and by default it's false. But if I press down, it is going to be true. And if I release the key, it's going back to false. And this is working pretty good. Although this by itself doesn't do very much, but if we put all of this into an if statement, and then indent the 2 lines below, then the ship is only going to move and rotate if we are pressing the down key. So let's try. And now by default, the ship doesn't do anything. But if I press down, the ship is moving. If I release the key, it stops moving, and so on. That's basically all you have to know about it. Although this would be a bit too basic of an input, we want to have something slightly more complex. For that, we can look back at input, and if I scroll up quite a bit, we are getting back to the top where we can see all of the methods. And in there, we have one called getVector. This is the one I actually want to use. This one takes 4 arguments for negative x, negative y, and positive y. Basically all the 4 directions. And then it is going to return a vector with the direction we have specified. That way, we can get all 4 directions in a single line of code. The way you would be using that one, back inside of player.gd. I want to create a new variable, which I'm doing with the var keyword. Let's call this one the direction. And the direction we are getting via input and then get vector. Now we have to specify 4 inputs. And we could be using the default options here. For example, there's UI down. We would also have UI left at some point, but those are kind of clunky. A better way of doing that would be in project settings, and there we have an input map. This allows us to specify custom inputs. The way you would be using that is you are first specifying a new action. For example, left. Then you get a new action, and to this action, you can add a key, which you do by pressing this plus icon. And then you can simply look through what kind of key you want to associate to this action. Although most of the time in this dialog, you simply have to press one keyboard button, and then Godot is giving you this key. So if I press left, we're getting the left key. If I now click on OK, we have added one physical keyboard button. You could, if I click on the plus again, also add other kinds of input. For example, if you want to have a joypad, this would also work perfectly fine in here. But that's not what I want to do. Instead, I want to create a few more actions. We want to have an action for right, an action for up, and an action for down. And then for all of those, I'm going to click on the plus icon and then simply press right on the keyboard for right. For up, I do the same thing, except now I press up. And finally, the same thing for down. For this one, I'm going to press down, and now we get left, right, up, and down with the associated actions. That's all I need in here. And now, if I go back to my script, and if you press Ctrl and Shift, you get a bunch of hints. And there you can already see we have down, left, and right. Left is the first one we have to include here. This would be -x. Next up, we want to have +x, which is going to be right. And all of those you can find inside of input. There you can see -x, +x. Next up, we have -y. And be careful here, in Godot, -y is going up, because the coordinate system for the window starts in the top left. Can be a bit confusing sometimes. But basically, we want to have up for this one, and finally, the last option is going to be down. And I am running a bit out of space, so let me expand this window. And what you can also do in the top right, there's an expand window. That way you have a bit more space. All right, with that, we are getting a vector. And let's print what we are actually getting. So I want to print the direction. Now run the game. And now we get 0 and 0 by default. But if I press on any of the arrow buttons on the keyboard, there you can see we get a direction that looks pretty accurate. And also, if I press down, you can see the ship is moving, and that happens because of this if statement. Although that we don't actually need anymore. So let me get rid of all of this. Instead, what we want to do is get the position and then add the direction and multiply it with some kind of speed. Let's say 500. Also, don't forget, we want to multiply all of this with delta. And now if I run all of this, we can see that the ship is moving along with my keyboard input. That is looking really good. Nearly done with this part. The last thing I want to cover is that this 500 right now feels a bit generic. I would rather have a variable that stores the speed. And for that, all the way at the top, before we are working with the functions, you can specify var speed and then set it to 500. And this would be a global variable. It would be available in all of the functions. However, this direction would be a local variable. It would, for example, not be available inside of the ready function. If you have no idea what that means, look up scope. It's quite an easy concept. In my case, I want to multiply the direction by the speed by delta time. And the output is going to be identical. So that's still looking really good. On top of that, what you can do in Godot, before you are declaring a variable, you can add export. And this, in terms of the game, is not going to make any change. However, what it does do, if I minimize the code again and go to the 2D scene and select the player, we now have another attribute inside of the inspector. 500 by default, but I can change this to 200, run the game again, and now the ship is going to move significantly slower. Basically, via export, we are declaring that a variable should be changeable via the inspector, which for some more complex games can be incredibly useful to fine-tune things. Although you don't have to use it, it's a fairly subjective thing if you like it or not. Okay, one last thing before we finish this part, and that is, when you are declaring a variable, sometimes you want to make sure that you only have one data type. For example, I want this speed to always be an integer. To make sure that you always get that, you can add a semicolon, and then you specify the type. For example, this would be an integer. That way, this number can change, but it always has to be an integer. For example, what I couldn't be doing inside of the ready function is assign speed to a value like test. If I do that, Godot is going to give me an error that we cannot assign a value of type string as integer. Now, to make this a bit easier, what you see a lot in Godot is this kind of setup. What that means is that whatever value we initially assign to this variable is going to be the data type of this variable. Meaning for speed, we are assigning it an integer when we are creating it. And this data type cannot be changed anymore because of this semicolon. Because of that, this line is still going to throw an error. But if I remove it, it disappears and Godot is happy again. I can now run all of this and you can see the game runs just as before. And I guess a speed of 500 feels significantly better. So let's try this again. And there we go. Now we can move the ship around. And with that, we have made quite a bit of progress.